Hello and welcome back to the Artificial Intelligence Masterclass. This is Kirill Eremenko, and in this section we're talking about variational autoencoders. Now in this first tutorial I wanted us to take a quick pause from intuition and actually understand the purpose of variational autoencoders in this model. What purpose do they serve? Why are we introducing variational autoencoders into this model? Understanding the purpose will help us go through the rest of the variational autoencoder tutorials much faster and get the most out of them, including the practical side of things later on. So here we're at the article that we recommend for this course, worldmodels.github.io, a wonderful paper or blog that explains a lot of the things that we're doing with this model. And so let's scroll down and actually have a look at the model itself. So this is where they start talking about the variational encoders, and we'll get back here in a second. But for now, I just wanted to go all the way to the appendix over here. So if you click appendix, I'll take you down to the appendix. So here you can see this model, which you are no doubt already familiar with, where we have our inputs here, then we perform all our convolutions and other operations, and then finally we get to this part here, which looks like a bottleneck, and in fact it is a bottleneck, and then we go back to the reconstruction. So this is the variational autoencoder. We'll look in more detail into this specific structure in the following tutorials, and it will be very clear after that. But what purpose does this serve here? We've got the input and then we've got the output. What is this variational autoencoder doing? Well, what it's actually doing, the variational autoencoder is the component of our model that creates the dream. Now, we've already talked, and Fadlan has mentioned this many times, that the idea behind this model is that we are allowing our artificial intelligence to dream and then come up with solutions in its dreams. So here you actually see some examples. So this is one of the clearest examples here, that this is the actual observation from the environment, and this is what we get encoded in the end. So this is the dream that the artificial intelligence is going through, and somehow we need to create it. That's where the variational autoencoder comes in. So now we can look at it in a bit more detail. Now that we know, overall that's the purpose, to create the dream. How does it create the dream now? So if you look here, you'll see that we've got the image that's coming in, then it's been encoded with our autoencoder, which is actually a variational autoencoder. But for now, we can just think of this as a normal autoencoder. It's been encoded, then we have the bottleneck or the middle of the autoencoder, or it's also called the latent vector in the middle, and then that information, that compressed information, is used is decoded into a reconstructed frame. As you can see, the quality has dropped a little bit here. We could do this with a normal autoencoder, and indeed we could encode it and then decode it, and that's what we would have. And we would have a compressed environment. So that's one of the benefits. We'd have like a compressed version of our original environment. And that's one of the benefits of using an autoencoder, is that we can take a environment with millions, or sometimes in some cases it goes up to billions of parameters. I think somewhere here in the notes they comment on that. I'm not sure which one it was. But basically an autoencoder allows you to compress this environment into from billions of parameters, really reduce the parameters and extract the features that really matter for this task at hand. Perhaps the color of the wall doesn't matter, or the texture of the wall doesn't matter, or the color of the ceiling doesn't matter, but how these monsters, in this case, how these monsters are moving and where the missile is flying at you at which speed, that does matter. So extracting the features that actually matter, so training the autoencoder in a way to extract the features that actually matter, that's already a step forward. So an autoencoder would allow us to construct a compressed environment, a compressed version, a compressed reality where we can train our model and then take that trained model into the real world. So that's what an autoencoder would do. But why do we need a variational autoencoder? So that's where the dream comes in. When we dream as humans, we don't actually see the world exactly as it is. Sometimes, but probably rarely. Most of the time it looks a little bit different. So here's a screenshot. Here is perhaps a dream, like a dream version, what we might see in a dream. Or we might see something like that. We might see something like that. So something slightly different, a modified version. And this is where the variational autoencoder comes in. Because in the middle of a variational autoencoder, it has a stochastic component. Here are actually some more examples. So there's a screenshot, there's original, there's a reconstruction. So there's many ways that it can reconstruct it, and that depends on how this latent vector was sampled. So let's go back to what we were talking about, the stochastic component. So here, as we will see in the intuition tutorials, in a variational autoencoder, this component over here has some stochasticity, so some randomness. The way we encode and decode is not fixed. It's not just like one vector. Every time this operation happens, some sampling occurs, and that allows us to create slightly varying dreams every time, slightly varying representations or reconstructions. And that allows for more diverse training. It allows us to, allows the artificial intelligence to go through various, even with the same inputs, go through various different iterations. So for instance, here's the input, but the artificial intelligence is actually dreaming lots of different stuff, lots of different scenarios, and it's learning from all of them. So not only are we compressing the input space, like for instance, we're getting rid of these colors on the green, for example, as a example that might not be important to the decision-making process. Not only are we compressing the input in space, but we're actually creating slight variations of the input space all the time, and effectively we're increasing our possibility for training, our opportunity for the artificial intelligence to learn. That's how the dreams are more powerful than the actual, can be more powerful than just the actual reality that we have. So here you have an example, once again, of the actual observation and what's happening in the dream of the artificial intelligence. So that's, in a nutshell, the purpose of introducing variational autoencoders. As you can see, it's a very, very exciting idea, very exciting approach to solving this challenge and to helping our AI learn. And in the following tutorials, we'll learn intuition behind variational autoencoders, and then you will code them in the practical tutorials together with Adlan. On that note, I hope you enjoyed today's tutorial, and I look forward to seeing you back here next time. Until then, enjoy AI.